Let's say a user asks a planner agent to summarize her open Jira issues, and this is a multi-agent system. 3 agentic hops later, the request lands on the Jira MCP server, but 2 questions have no clear answer: who the request is for and who authorized that request. That is the problem this session is about, and the standard that solves it is called ID-JAG. Over the next few minutes, we will cover 3 things: why forwarding a token down an agent chain breaks, and why the MCP spec won't allow it, how ID-JAG's two-step exchange works parameter by parameter, and when you would reach for this versus plain token exchange or Entra's on behalf of flow. By the end, you will know exactly which flow your stack needs. A user, let's call her Jane, asks a planner agent to summarize her open Jira issues. The planner then calls a research agent, and the research agent in turn calls the Jira MCP server. This is 3 hops, and Jane only touched the first one. By the time that request actually lands on Jira MCP, 2 questions have no clear answer. Who is the call actually for, because the original user has no representation in the request, and who is allowed to make that request, because nothing says which agent is calling or on whose behalf. The obvious fix is to forward one powerful token down the whole chain. It works on the first try, however, is the fastest path to a breach. 2 things break here. First, if that token belongs to a shared service account, Jira has no idea that this is for Jane. It returns everyone's issues. Second, a token minted for Jane in the planner is now replayable by anything downstream against any system that accepts it. And if you're building on MCP, this is not just a bad idea, it is specifically prohibited in the terms of token pass-through. An MCP server must reject any token that was not minted for its exact audience because it can be used as an open proxy into other systems, which is a very high security risk. Now, the mechanism that solves for this is called OAuth 2.0's token exchange, in short RFC 8693, where instead of forwarding the incoming token, the gateway trades it for a new token which is scoped to exactly the new callee. The subject stays the original user. An act claim records which agent is acting. The audience narrows to one recipient, and the scope narrows to what that hop needs, as you can see here depicted in the right hand side. Now, this is a simple case which is one exchange, and your gateway can act as a security token service. But this only works if the target trusts your gateway. What happens when it does not? And there are scenarios when this will also occur. In those scenarios, ID-JAG becomes important, which is an IETF draft and the basis of Okta's cross-app access. Let's go into this. Now, a token which your gateway mints is only worth what the receiver thinks of your gateway. This can be when your target has its own authorization server, which is, let's say, a different vendor's application, a partner's MCP server, anything basically outside your trust boundary. And in this case, a token your gateway mints is not good enough. In this case, that resource needs to make its own decision, where ID-JAG actually comes in. ID-JAG lets the enterprise IDP broker access between 2 applications with no per user consent click in the middle. This is a 2-step exchange, and this is the part where it architecturally solves the problem. Now, the first step is the caller presents an identity assertion to the IDP's token endpoint, which can be an ID token or a refresh token. Now, here 2 parameters actually matter. One is a requested token type set to the ID-JAG token type, and the audience here is set to the target resources authorization server. Now, with this information, the IDP returns an ID-JAG, which is short-lived, signed, it names the user, and it is audienced to that specific resource. Now, notice whatever this IDP is returning, it is not an access token. You cannot call anything with it. It is just a grant, a portable signed statement that says this is the user and this application may ask you for access on their behalf. The second step is that caller takes that ID-JAG to the resource's own authorization server and redeems it using the JWT bearer grant from RFC 7523, where the grant type is JWT bearer and the assertion is the ID-JAG. Now, the authorization server applies its own policy and then returns an access token. And that is the whole point. The resource authorization server here stays in full control. It directly decides whether to honor the ID-JAG at all and what scopes to grant. Here, your gateway does not get to assert access into someone else's system. It just presents a verifiable claim about the user, and the other side then makes a full decision. Now there is an MCP specific profile of cross-app access for exactly this case, and this fit with MCP is not a coincidence. An MCP server is also an OAuth 2.1 resource server. It has its own authorization server. The MCP spec requires it to validate audience and reject anything else, and ID-JAG produces precisely that, an access token issued by the MCP server's own auth server, audienced to itself. And here the delegation survives the round trip. The user stays the subject, the acting agent is still recorded, so Jira returns Jane's issues, and your audit log still knows which agent actually asked. Now, looking back at the entire discussion, this is same foundation, 3 different profiles, everything with RFC 8693 beneath. What should you pick? Now pick generic RFC 8693, which is one exchange where your gateway is a security token service, and this is best for internal services that already trust the gateway. Pick ID-JAG or cross-app access, which is 2 exchanges, the first one being an intermediate ID-JAG and the second one being a JWT bearer redemption at the resource's own auth server. And this is best for cross-app and cross-vendor access brokered by the IDP. And then you have Microsoft Entra on behalf of Flow, which is also 2 exchanges using requested token use on behalf of with actor facet claims, best for Microsoft-centric estates. Now, apart from these 3 scenarios, what if the target cannot participate at all? You can fall back to a gateway issued scoped token, and token pass-through remains the absolute last resort. Now, where does TrueFoundry sit in all of this? In TrueFoundry, this turns on when your agent identity is IDP backed. The agent authenticates to your Okta or Entra tenant. The gateway validates that JSON web token and resolves it to a registered agent identity. And from there, it can run the exchange against your IDP on the agent's behalf. On the agent registration, that's one line, which basically includes auth type is token exchange. The gateway then handles which profile to use, does the 2-step, and enforces who may call what and who may act for whom before any token is minted. This is basically open standards underneath with one line of config on top added by TrueFoundry. Full details are in the agent identity and governance docs. For that, the link is shared here.